Winter, a season of stark beauty and serene landscapes, often brings with it a fascinating meteorological phenomenon, fog. This ethereal veil, a cloud that descends to Earth, transforms familiar surroundings into scenes of mystery and intrigue. Fog, in its many forms, is a captivating reminder of the intricate workings of our atmosphere, particularly during the colder months. Its presence, while sometimes disruptive, adds a touch of magic to the winter landscape. Join us as we delve into the science behind this captivating phenomenon, exploring its formation, types, and impact on our lives. Fog, in essence, is a cloud that forms at ground level. It consists of tiny water droplets or ice crystals suspended in the air, reducing visibility and creating an ethereal atmosphere. The formation of fog is a delicate dance between several key factors, all of which must align for this captivating phenomenon to occur. These factors include cold temperatures, high humidity, open air, and a lack of wind. Understanding how these elements interact is crucial to unraveling the mystery of fog. Cold temperatures play a pivotal role in fog formation. As air cools, its capacity to hold water vapor decreases. Think of a sponge. A cold sponge holds less water than a warm one. Similarly, cold air reaches a point where it can no longer retain all of its moisture. This critical point is called the dew point. When the air temperature drops to the dew point or below, the excess water vapor condenses into tiny droplets, forming fog. Humidity, a measure of the amount of moisture in the air, is another crucial factor in fog formation. The higher the humidity, the closer the air is to saturation, the point at which it can hold no more water vapor. When the air is saturated, any further cooling will cause condensation. This is why fog is more common in humid environments, particularly during the winter when temperatures are lower. Wind, or rather the lack thereof, is the final piece of the fog puzzle. Wind acts as a dispersing agent, mixing the air and preventing the concentration of moisture needed for fog formation. In calm conditions, however, the air remains relatively still, allowing water vapor to accumulate near the ground. This is why fog is often associated with calm, windless conditions, especially during the winter months. Fog, like snowflakes, is not a one-size-fits-all phenomenon. There are various types of fog, each with its unique formation mechanism. Two common types, particularly relevant to winter, are advection fog and evaporation fog. Advection fog forms when warm, moist air moves horizontally over a cooler surface, such as a snow-covered ground or a cold body of water. Evaporation fog, on the other hand, forms when cold air sits over warmer water, causing water vapor to evaporate and condense into fog. Advection fog, a common sight in coastal areas during winter, occurs when warm, moist air moves horizontally over a cooler surface. Imagine a warm, humid air mass drifting inland from the ocean and encountering a landmass chilled by winter's grip. As the warm air passes over the cold surface, it cools rapidly, reaching its dew point and causing condensation. The result is a blanket of fog that can stretch for miles, shrouding coastlines in an ethereal mist. Evaporation fog, also known as steam fog or sea smoke, occurs when cold air sits over warmer water. This might seem counterintuitive, but remember, water evaporates even at low temperatures. When the cold air hovers above the warmer water, the water molecules evaporate into the air. However, the cold air can only hold so much moisture. As the air becomes saturated, the excess water vapor condenses into tiny droplets, forming a mystical fog that appears to rise from the water's surface. While fog undoubtedly adds a touch of mystique to winter landscapes, its presence is not without consequences. From transportation disruptions to health concerns, fog can have a significant impact on our daily lives. Understanding these impacts is crucial for mitigating risks and ensuring safety during foggy conditions. Fog's most immediate impact is on transportation. Reduced visibility makes it challenging for drivers, pilots, and seafarers to navigate safely. Road closures, flight cancellations, and shipping delays are common occurrences during dense fog events. The economic implications of these disruptions can be significant, highlighting the importance of accurate fog forecasting and effective mitigation strategies. Beyond transportation, fog can also impact human health and agricultural practices. The tiny water droplets in fog can exacerbate respiratory problems, particularly for individuals with asthma or other respiratory illnesses. In agriculture, fog can create favorable conditions for fungal diseases, potentially damaging crops and reducing yields. Understanding these less obvious impacts is crucial for protecting public health and ensuring food security. Winter fog, a captivating meteorological phenomenon, embodies both beauty and challenge. Its formation, a delicate interplay of temperature, humidity, and air movement, transforms familiar landscapes into scenes of mystery and intrigue. While fog's presence can disrupt transportation, impact health, and affect agriculture, it also reminds us of nature's awe-inspiring power and the intricate workings of our atmosphere. By understanding the science behind fog, we can appreciate its beauty while mitigating its potential risks, ensuring a safer and more informed coexistence with this enigmatic shroud of winter.